Hello, hello, hello. Hopefully we're live. Yes. Hope people are doing good. I'm gonna try music. We're gonna try with music today, so you might hear music. Which, yeah. If I get instantly kicked off YouTube, then yeah. So it looks like everything's good according to the stream health. Excellent. Very good. Okay. Right, we have a couple of things that I want to try today. Let's get you up on the other screen before we begin. I can't really see much. Okay, so here we are. Right. Yes, chat is up. Yeah, I barely know what I should learn how to live stream better. If I'm going to do it a lot. So, yeah, I'm going to work on the foundation today. I want to get descriptor buffers working. I have written a bunch of stuff about them. Although just the hardware. I don't really know how the extension works in Vulkan. I did some reading today on this article. Which just seems to kind of skim over things, but yeah, we've got like excuse me, we've got like a what is it called? Where is it? There it is. Yeah, so descriptor sets are now backed by VK buffers. There's no VK buffer view, which is strange. Where mem copy, you just do a mem copy. And then you index into them or something. I barely know what I'm doing, honestly. This has been super confusing, so yeah, I'm just gonna screw it, stream it, why not? Who cares if, you know, people think I'm lame. I think people who think I'm lame are lame. Yeah, so the idea is I want to get rid of this kind of mapping and unmapping. I might also have to just go offline, go quiet for a bit. Like right now. Alright, be right back. Alright, guys. Just a bit longer. Yeah, just adding some map levels to the textures. Just a quick thing that I could just do quick. Alright, we've got to check the other model type. Yep, I'm trying to do that extension. Right, we should be back now, for the most part. Just some more... I'll say it, it's just more important stuff came up than talking to people on the stream, so hopefully people can appreciate that. It is what it is, it is what it is. Anyway. Yeah, so, what am I doing? I'm trying to, I just thought temporarily while we're in the midst of things. Things are a bit scruffy. Yeah, for some reason, .gltf files of the resource cache, for some reason, it's dying. It's like it's being deleted twice. I kind of can't be bothered fixing that at the moment. Should I? I don't know. Anyway, the first thing I actually want to do is, yeah, just move to this structure for enabling things. It just seems so much simpler. I mean, there's nothing wrong with it. I'm just kind of like enabling things in Vulkan 1.0 kind of way. And I know Ratchet has suggested this in the past, but yeah, I don't think there's any issue. It's just, you know, if I'm going to start enabling a lot of features, there's going to be yeah, we're just going to end up in a situation where we're going to have like lots of different little structs when we could just have enable version 2, which, you know, a lot of stuff is core anyway. So yeah, we're just going to pull out version 2, version 3, and maybe that asotropic answer. I never know how to say it. So yeah, we're going to start simple today, and a lot of it is just going to be me trying to figure out what the hell's going on. Yeah, so we're back. Hopefully people don't mind the music. I thought, you know, bit of a change. Physical. Yeah, I'm completely burnt out as well, so this will be a bit of a random stream. Bit low, bit more low key. Features. Yes. Okay. Bit more chill. Alright, what's in this? So, yeah, we want this. This is the thing we're going to be trying to do. Oops. The next thing is scale a block we need. Scale, is this in? Yep. True. Scale of blocks in here. What else? According to our thing, resource, whatever. Runtime descriptor array. Oh yeah, we need bindless. Forgot about that. What's in bindless? It is runtime descriptor array. Okay. Yep. We need this. This is for our textures, which are already bindless. Which are, you know, it's just more bind once, update later. More than anything. It's not really bindless, we're still binding. We need partially bound thingy. Is that version 3 or 2? What are we? Oh well, it's not in this.
10 seconds of transmission.
Partially. Yep, there it is. Same deal, I think. Okay, so that's all version 2, version 3. I could turn on synchronization 2, but does that all care about at the moment? So the idea, anyway, I'm going to go through like a foundation series with the engine. There's a lot of stuff that needs to be done at the foundational level. Yes, dynamic rendering and synchronization 2 are two things I need to fix as well. Yeah, we could do that. I mean, there's no reason to do sampler. Sampler anisotropic is so like nothing. It's a chicken nothing thing. No. Whoops. Oh. I copied the wrong thing. That's what I wanted to copy. So yeah, we're gonna go through this. It's kind of gonna be like a boring, in the sense that we're gonna have to just basically do a bunch of groundwork to set things up. That's not what it's called. Why isn't that not this? 2. What's the difference? I can imagine it's absolutely nothing. So this is actually quite convenient. Oops. Can we just grab the features, please? IntelliSense, what are you doing? Yes, thank you. And what is this called again? Sampler. Alright. There's no reason not to do this. Yep. Sure. See if I can do that. I hope so. It'll be kind of hard to see. So we're just gonna say this is necessary for one thing, because I've got partially bound. I'm partially bindless at the moment. I'm not using any type of descriptor. Sorry, buffer device address stuff. We only have textures. There is kind of like at this moment this UBO, dynamic UBOs, which are kind of in the middle of bindless and non-bindless, because we're not having to bind like multiple things over and over again. We can just update the same UBO, which, you know, is quite hot. So yeah, we effectively kind of fake bindless by using dynamic UBOs. But you know, we don't really need to do that if we can use an index and just get around descriptor sets and all that kind of stuff. Hey, thanks Hipstone update. Yeah, I saw that clip. Yeah, you trying to integrate DLSS. Things going crazy. Everything's shaking. That's in the Discord, by the way. That's I am Akatazi maybe. I don't know. Hopefully having a good day. Thanks for turning up. So interesting. I'm mastering C# to move on to. I'm mastering C# to move on to C++. Any tips? I'm really like deep into C#. I tried starting C++, but it's definitely difficult. Or decently difficult. Okay. I wish I was someone else. Honestly, I know someone who is a professional C++ and C# programmer who would be able to tell you in detail what the differences are and what you should expect. I've never really used C#, so that's kind of I'm quite limited on my expertise on the differences between the two. I don't exactly know what would be difficult. That's the other thing. But I would say, you know, just like with anything, it just takes a bit of practice. I think people can get tripped up by pointers, and I'm not exactly sure how C# kind of hides that from you. Let's just make sure this is good. So yeah, I would make sure you just take notes, study, take your time. Recognize that C# gives you things that you can use to do UI off the bat, I think, with its .NET framework and all that kind of stuff. Whereas like with C++, you kind of have to like either use a library or roll your own. I would highly recommend using a library. So, you know, if you're trying to recreate what you did in C++ in C#, it's going to be it's going to be harder. But yeah, just stick at it. On and off for like 12 years. I worked professionally for 6 years in doing C++. Alright, looks like we have our features enabled. Yeah, because if boundless wasn't turned on, this would just break. Oh, yeah, we're still using that model. Yeah, I'm just going to leave that for now, just be super lazy. DLTF is not working. Whatever. Kind of don't really care about the file format, to be honest. For now, anyway. Okay. Oh, yeah, we should get rid of this. Sorry, I've got like so much random stuff like left over from when we tried to do SPRV reflection. So the idea anyway with this foundation series, where I just do the foundation, is to make like SPRV reflection so trivial that it may not even be necessary. Yeah. Because that's part of the problem right now, is like the descriptor set layouts that you have to kind of do manually. Are kind of like a pain in the neck if you're having like multiple graphics pipelines and things like that. It just kind of gets scruffy because, you know, I'll have to redesign the descriptor set layout over and over again. But if I just have access to a pointer and I don't have to do anything like set up things before, I can bind first, update later kind of stuff for buffers as well as textures. I think, you know, the graphics pipeline will get a lot simpler. Everything will just be like one big update in mass, rather than like having to worry about when you bind and because, you know, binding isn't, the graphics driver has to do some work to bind. So yeah, that's what we're going to try and do anyway. So yeah, unfortunately there's not going to be like, oh, this is a really cool feature that we're going to implement. There's a lot of it's going to be like, we're going to be rendering the same model, but slightly better for a while. But yeah, it's needed to be updated. Where is this thing that I'm looking for? There it is. So yeah, but after that we'll hopefully have a lot of flexibility when it comes to adding new features. That's the goal anyway. Yeah, and also if the music's too loud, let us know. This is the first time I've played music. There's a mixture of Final Fantasy, Ratchet and Clank, some old Mega Drive / Sega Genesis stuff. Which, you know, classic music, you know. Like this one, classic music. Metal. I keep calling it Metal Slug, it's Metal Squad. From Thunder Force 4. It's such a good track. Okay. I didn't include that anyway, did I? Yeah, just a bit of clean up. I think, yeah, what I'm going to do actually is just delete a bit of code. Let's see, do I want to keep this though? I kind of want to put this in like a branch, but it's kind of like, you know, just having a big load of comments in our code, it's kind of scruffy. I will kind of put this in a different place. I think that's the best place. I probably won't end up using it, but yeah, because if we're going to worry about the foundation, then this SPRV reflection stuff is going to be completely different by the time we actually work with it. So, because our descriptor set layouts will be a lot simpler. So yeah, even having the commented out code is probably not a good idea to have that laying around. I'll just throw this in here and just kind of save it somewhere. Old descriptor? No. SPRV reflection code. So we might end up not using this at all, but you know, it's better because what I'm gonna do is gonna push, because we have done some other stuff that I do want to keep, and if I'm gonna start rewriting things, I might as well have a good clean starting point. Just make sure everything's good. We have mid maps, which is, you know, chill. That's like completely trivial to add. Yeah, okay, so don't think there's anything else. Alright. Yeah, okay, so there's just... I'll leave that lying around. There's no reason not to. I mean, it may slow down compile times, and if I'm not using it, it's kind of redundant, but... it is what it is. I mean, let's just check the fragment shader real quick. What did I do here? Just change the location of the light and the intensity. Yeah, nothing crazy. Alright. Let's do that. One moment, guys. Yeah, sorry about that. Hi, Mimic. Hope you're having a good day. My game is going to be, hopefully, if I get anything out, which is a big, you know, I am trying, but, you know, gotta be realistic. I'm quite far away. What I want to do is kind of like an exploration type game, where you kind of like, it's like a collectathon. I feel like going back to a 3D platformer, but without with a, you know, kind of a puzzly aspect to it, rather than like a really intense Crash Bandicoot type thing. So yeah, I've got like a vague idea of what I want to do, but for now it's like I've got to with this engine. I've got to okay. I'm gonna get a stash on this. This is just me messing about with that'll be committed. We don't want build. What does it want? So yeah, that's what it's gonna be like. Yeah, we'll see. We'll see if it's fun. Yeah, think games like you know, Spyro, kind of like Banjo-Kazooie, you know, even Conker's Bad Fur Day, I guess. Like Mario 64 kind of thing, where you're kind of like platforming plus trying to figure out what to do. But you know, that's like a big far off goal. I think I've got like smaller games that I want to make up until that point, but that's like the big North Star that we're heading towards, if that makes sense. Why are you being silly? Git stash drop. Don't want that for now. Git status. So please got rid of that. Oh, did I leave some files and examples? Oh, alright, this is an easy fix. Yep, go away, go away. Yep, and these two need to be deleted. And then we should have clean repository. Yep, alright. Get out of here, get status. Yes, new file. And yeah, let's just commit this for now. Oh, I'm in vendor. Let's get out of vendor. one more status. Pads, already done that. So there's small improvements. We added a mip maps. Is that MIPS? Two textures. That's, I always call mip maps. It's not. That's not quite right. MIP textures. And what's that do? Yeah, I'll just commit that. That's fine. Nothing crazy. Extremely minor improvement. Oh, that was the other thing we did. We updated our initialization to be more up to date with the current Vulkan 1.3. Although we're using 1.4, we're still in 1.3. Just because I want to be a little bit behind the bleeding edge, so drivers are a bit more stable. Okay, so yeah, this is just going to be us trying to figure out what the heck to do in the sense of this buffer device address. So what I don't quite understand about this, I've got the source code up here, is how does we have a descriptor pool, descriptor set layout on a descriptor set, and I'm like, I thought the whole point of buffer device address was that we don't have this to begin with. That's true. I mean, yeah, 1.4. I haven't heard. I think 1.2 was like the biggest. 1.3 was pretty huge as well when it came to Vulkan, but it wasn't as big as. I don't know about 1.1. I just know I've studied 1.2 quite a lot because this is where the beginning of Bindless started. This is where buffer device address came from. And a few other things that I'm like taking for granted that exists. Ah, you still need descriptors for images. Good to know. Do you have any experience working through driver issues? Honestly, when I've had driver issues in the past, I literally go, oh, why is this crashing all the time? Oh, I guess it's I pull my hair out for like a week and then I realize once I update my drivers, it goes away. If you do have an issue, honestly, it's maybe better to just file it, depending on what your vendor is, file a bug. If it's a new one anyway, because you might find if you're trying to file a bug, you've got a bug that's that issue already exists out there, and if it doesn't, then you can always file it. Yeah, OpenGL is horrendous for that kind of thing, especially when you're trying to get it running on other people's computers, which is a big issue. If you've got no validation errors, you can at least be somewhat sure that, for the most part, again, for the most part, this is very caveat, there's a big asterisk here, that it's going to be relatively stable on most platforms that are similar to yours. Alright, so okay, so buffer device address. I swear this tutorial, I do have the article here. I was going through this earlier. So yeah, again, I'm not gonna. I hope this. I don't know what to say. I don't know how to say this. So I've decided to just kind of like stream anyway, even though I feel like I'm unprepared. I feel very unprepared for this stream. Honestly, I don't exactly know how to do this. And I hope that's not going to be off-putting for people. But I thought, worrying about what other people think of me is a road to a miserable life. So we're just gonna see what happens. Yeah, so we're going to be doing all sorts of shenanigans. Maybe there'll just be me reading for a bit. Oh my goodness, yeah, Nice, yeah. Yeah, good luck with that fix, Daniel. Hopefully you do fix it. It's a tough one when you get a driver issue, because a lot of the code that you're trying to work with isn't yours, so it's hard. So you know, I appreciate it's a struggle. So yeah, if I just get a push constants and push up something, then I can index into a thing. Now, how do I do that at all? Oh yeah. Yeah, I mean, I think Ratchet and I have both experienced the same issue where you do something like vec2 and then you add something like 0.2 in one. No, you add like vec2 comma, I don't know, vec2 open parentheses 2 dash comma 2. And then that like works on NVIDIA and it breaks on an AMD because it's technically not a float, and the compilers are all different. OpenGL's like really annoying like that. Like, but yes, BRV is honestly it's a big reason why I like Vulkan more than OpenGL. Although Vulkan has its own annoyances, but yeah. So yeah, this is HLSL, but I went through this and I was just... I just don't exactly remember. I do know that descriptors are basically just a big chunk of memory. I mean, I have your notes here, Ratchet, as well. What you told me. But yeah, I'm just going to have to figure out from first principles, honestly, just how do you even do this? Because this is the size thing. But obviously, it seems like once you get it right, you can just do a mem copy. Because the buffer is apparently backed up by what we're doing on the shader. Yeah, so I was hoping that the Vulkan tutorial from 2016 has like a really simple example. But I guess if I don't know what I'm looking for, there's a big issue with that one. So yeah, I'm just going to be parsing stuff. Hopefully that's chill. Oh yeah, I mean, I've never been web development. That's cool that your family's kind of like a you like a lineage of programmers. Yeah, but it is a blessing and a curse being so like low level. I mean, you know, having access to pointers in a general sense is really nice, but it's also like it leads to so many more complications and stuff. So yeah, so this is to do with VMA. So there must be some kind of like VMA allocation that you have to do for buffers, right? So this is, what is this for? This is for a depth image. Yeah, all right. Loading meshes. Hey man, how you doing? Yeah. Yeah, cons you control memory. Pros you can control memory. That's that's the pros and cons of that kind of stuff. So here we go. Okay, so it's creating a buffer. All right, let's just see in the source code. All right, it creates a buffer and it must do something different here, right? Than what you do with descriptor sets. So there's no descriptor set layouts for these buffers at all. It just creates literally just creates a buffer. Yeah, host accessible. One moment. Yeah, I'm good. Thanks for asking, man. I just thought I'd just, you know, stream regardless if I feel ready or not. So this is going to be a bit of a different one. There we go. Sorry about that. So yeah, I might be interrupted now and then. I might have to go quiet, but you know, it's not like you constantly need me yapping non-stop. Right. So this is the difference, right? We have this buffer device address info. I think this is what it was talking about here. No. Where was this? Oh my goodness. Stop telling me about DirectX. It seems like DirectX as well, this is just an aside, has gone with descriptor heaps, which seems like a worse version of descriptor buffers, because it just seems to be like a really restricted version of a descriptor buffer. You know, that's something I've been kind of learning about, which is kind of interesting. Yeah, so this is the confusing part. Yes. I think, what should I do this for? I think if I just jump in and just try and convert everything, we're just going to get in a situation where everything goes wrong. I think what we should do is the simplest. We should try to have a buffer that just isn't updated at runtime. And therefore we can have like a kind of like a safe testing ground for this kind of stuff. Yeah, so I'm just going to be reading a bit of code at the moment. So this is so they're still doing vertex buffers and index buffers together, which is fine. That's aliasing, but it looks like it's the same. It's the same idea, right? What is the difference? So it goes this. Okay, so when we create the buffer, we say buffer usage, blah blah blah. Alright, so we need to kind of like investigate a alternative code path to be setting up structs, buffers, which we can do. Because if we're going to have like a testing buffer first that we're going to move to bindless, we're going to have to pull out the descriptor, bloody blah, what is it called? Descriptor set layout. Otherwise, you know, we won't actually figure out what's going on. Right, where is it? So we have a create buffer struct. So create buffer. So yeah, this is the one I was thinking about doing. No, it wasn't. It's the, not the uniform. I want the SSBO. I'm going to try that first. Because that has its own random descriptor set layout. And if I can just like get rid of this, this would be so much nicer. That we just, you know, index into this by, I mean, it's an SSBO, not a uniform, so there's kind of like a bit of muddiness here. Like, how do so according to my understanding, there's a piece of memory, there's a piece of hardware on the GPU that contains a buffer of memory. With modern hardware, this already exists anyway, especially with the drivers being updated and stuff. So even if I'm like saying there's like a register or whatever, like, oh, this is a bound register X or whatever, this isn't true anymore. There's literally just a piece of memory where, you know, this lives, and that the driver is doing this mapping. But now we have access to this like we have access to this pointer ourselves, so we can actually just access this pure this piece of memory without having to worry about any setup or binding time or anything like that. So that is what I'm going to try and do. Alright, so the descriptor set layout. Where's the handle? That's the one. Yeah, this is the one I want to. This is the one I want to try. Because this isn't done. There's no complicated stuff. It's just a huge buffer of memory. It's storage. And when we create this buffer, we have the sampler. Invalid the binding and the index. And where is the actual creation of this guy though? Is that what I just went on? No, this is what I wanted to see. So we need like a separate code path. We need like a second function here that does like a bindless version, which, you know, uses a different usage struct. Alright, so that's how we're going to do this. We're going to, so turn to buffer handle, create bindless buffer, and for now it's going to be the same. I want to be able to use the structs for now. I may end up getting rid of these structs, but there's already so much work already been done that it, you know. I do actually also want to get rid of the idea of having like a data member, but it's not that bad right now. So for now, just copy and paste this, exactly the same thing, and we'll change things as we go. Cool. Okay, I think anything will be different here. What is this? This is just R data. There's no VK info. So as soon as we hit this, everything here changes. And yeah. Now, how is this tied to a descriptor? Again? Set resource name, what's this do? This is debugging stuff. I'm sure we can do the same in a non-bindless mode, so yeah, okay. Right, let's begin the allocation, creation, and setting of this. Cool. Alright. Have I watched Vulkanized 2026? Have I? That's a good question. Let's see. Vulkan. I might have seen the older ones. I've seen some. Yes, I've seen the 2015 talks, but not the 2016 one. 2015. Flip it heck, we're not that old. That'd be a craziness. Second. Yeah, so I've watched a lot of these, but not the new ones. So I might watch. Yeah, timeline semaphores is definitely something I want to change with the Foundation update. Yeah, definitely worth checking out if you've never seen these before. And if you're starting with Vulkan, there's like a 2024 one, which is like a great intro to Vulkan. I think it's still relevant. Does it have any weirdness? No, I think it's a good pairing with How to Vulkan. I think it's like a good way to reinforce what you've learned. I watched it a couple of times anyway. Not recently, that was a while ago. Anyway, is there any good 2026 Vulkanized talks? That timeline semaphore one looks good. Because again, that would be nice just to rip out the binary semaphores that I'm using. Alright, while you're entering that, I'm going to kind of figure out... VK get device address. Okay, so this is part of it. So one step at a time. Let's grab this and kind of see what we have here. So it has this. We have the size, which is just a creation struct. If it's greater than 1. Usage. Type flags. Now this better be not abstracted. Yes, it isn't. Okay, good. So this means I can set it up as bindless by this flag. But if we're running this struct this function anyway, then we can just all this together for now. So that's the first step done. Ugh, get off. What's the next step? So you allocate. So this is host visible. This is our allocation struct for VMA. I don't think there's anything different here that I need to worry about. Yeah, host visible. I should just make sure my allocation isn't bad. Because it's not bad in the sense that I've got it wrong. It's just like, has VMA updated, and I've been using old VMA things. I've done that before, so it's always nice to double check. So we have sequence, host. Yeah, okay. Nice. Everything's good there. You still need binary semaphores for what is that? WSI. That's the Windows subsystem interface. That's the extension we use for Windows, right? Yeah, I think if I look at my notes, that's in there somewhere. In give me a minute. What would this be? Swap chain? No, extensions. Yeah, it's the swap chain stuff. Oh, really? But it's the extension that you need to activate for. Where have I put this? not validation. Anyway, I might be getting confused between surface and swap chain, which is probably... Anyway, getting distracted there. So the VMA create buffer is likely different than what we've been doing. So, or if it is, again, I'm just going to make sure that we're doing the similar things. So that's the creation struct, that's the memory. So then we have the buffer, we have the allocator, and the allocation info sounds good. We have the same setup. We have a get the name of the buffer. Okay, so here's I think where everything goes a bit different. Hello Heath, how you doing? Hope you're having a good day. You can convert between timeline and binary and vice. Yeah, I think I had like when I did binary, I was like, oh, I need to support timeline and binary and dynamic rendering that uses timeline and dynamic rendering that supports binless and then dynamic rendering that doesn't do that and blah blah blah. So I had like 1,000 different code paths that all did like 20 different things. I'm aware that you can have both, but holy, it got scruffy fast. Oh, that's called Obsidian. It's like a wiki inspired. Well, you can make your own Wikipedia basically, and that's what I've tried to been doing. With hyperlinks that go to different places. And yeah, it has like a nice little neat graph that you can use. So all these connections are like relevant, like what are descriptor sets, then I can go to like you know anything about descriptors, lifetime push constants, and it's kind of like a nice way to like once you've studied something, it's like I try to connect all the ideas together or what I already know, and this is what it's kind of useful for. This can get a lot bigger as well, and the colors are the topics. So Vulkan, performance stuff, operating systems, C++, which is quite small because I don't really study it as much anymore. Yeah, it's kind of useful, and I use Git to manage it across different computers. But yeah, it's my own private. They call it a second brain, but it's just documentation with links. That's all it is. Yeah, it's useful. It just takes a bit of dedication to keep up, and to keep correcting your notes, because I have some corrections I need to make on swap chain stuff. But the idea is I have like notes that are less than 500 words that I can link between, that I can reference and stuff. This is when I say that I don't know if you saw my video where I talk about what I do when I'm doing revision every day. This is what I'm doing. I'm going over this, I'm like clicking on, I don't know, how to create a vertex buffer, and I'm rereading how I did that, with like code examples and stuff. So yeah, it's if you do want it, it's quite useful. Okay. So he is using device address. How many times is he doing this, I wonder? Is he doing it more than once? No. Interesting. I know Ratchet's engine, who's in chat if you get to see him. He's using multiple indices that go into the push constants, which I might try. So we just set up a push constants. Oh yeah, this is called Obsidian. This is what you're talking about, yeah, the note-taking app. It's is there a it's free, but there's a commercial side of it where it'll basically if you want the commercial side, all that is for people who can't be bothered setting up like an alternative way to back up their notes. The Obsidian company will back up your notes for you, but at a price. Outside of that, it's completely free. Yeah, this is Obsidian. Yeah, free to download. I think it works on Linux as well, if you're a Linux guy. I'm sure it works on Linux because I use it on Linux. I don't know why I said I think. Anyway, let's dig into this a bit more. Yeah, no problem. No problem, PK. What was I doing? I was setting up. I kind of got a bit distracted with moving to a different part of the code. Let's take a step back. Okay, so okay, so the buffer device address is the different thing. Right. So we don't do this. Initial data. Okay, so this is only if we have something already. I'm sure that's fine. I can't imagine why that would be an issue. So yeah, we're just going to copy paste this wholesale and rename everything and rewrite everything. BK buffer device address. I'm only copying this here honestly so I can actually see what I need to do. I'm not actually going to use this. Yeah, buffer device address. Oh yeah. Yeah, it's... You don't have an S tag? Oh, derp. It also completes a buffer. I was gonna say. Anyway, so be device, address, create info probably. Oh, it is extension. No, it's not. Buffer. So we want the buffer, which was this guy. Sorry, gone off really far away from the mic. Buffer device address info. Right. Okay. And now with that we have an index with the function call wrong thing with this, right? So we have a buffer, now we have a way to access it. It's almost like I need to return the right, I'm just gonna get rid of this for a minute. And we need the device. I think I went through this habit of calling everything Vulkan something device. Vulkan this, Vulkan that. Because I assumed I would have a device that wasn't called, I don't know. Kind of stupid, but whatever. So this returns a VK device address, okay. address. What is this? Alright, yeah, it's just a number. Oops. Okay, so it seems really simple actually, the difference. So you have the address. You have the handle. So I've got a handle that I'm passing around that generates the struct. It feels like to me we need another thing here, the buffer device address. Yeah, I think. Yeah. If we're going to use this, we're going to have a. Yes, it makes the struct a little bigger, but considering this is the buffer device address. No, yeah. I'm going to buffer address. Because that's what it is. In this context, anyway. Address. And yeah, we're just going to assign it. We have the handle set up. Because that's the actual important part, getting this address guy. Buffer address. Cool. Right. You name it, device address. Yeah, I mean, I guess you can have more than just a buffer in here, but for my struct, it's just called buffer. So to me, it seems like in that context, it makes sense to call it buffer address because that's what we're actually handling in this handle. I'm sure it doesn't matter. It's like one of those things, just preference, isn't it? Okie dokie. So interestingly enough, we create the buffer and then we don't do this. This is the difference, right? We don't actually bind it. We don't put the buffer into a descriptor set and then we don't do create descriptor set. That's the difference. Okay, let's what I'm gonna do, just so I don't end up messing this up, I'm gonna leave that there, commenting out, and we're gonna create a bindless buffer, and we should get the handle back. We don't want this. Okay, so our buffer is now, this is our handle. So what does it do in this? So our buffer device address is then shoved into a push constant. Okay. So I guess I need to see the shader. And obviously I would need to figure out the size of the push constants, but that's trivial, honestly. Oh, there's a host address. I don't... Oh, okay, let's see. Let's look this up. Okay, so Ratchet has pointed out that there's something else here. So buffer device address. Is there like get buffer host address? So host address. This would be, I don't know, just kind of like, you know what, whatever. If there's a host address, there's a host address. I'll deal with that when I come to it. So we have the thing. And for this buffer, we know we are going to do something special. Okay, you map them persistently. I'm going to try and do the same, I think. Because then I can just do a mem copy at runtime. Who cares? I think that's actually something I should look up before I continue. I assume with buffer device address, the updating of the buffer is exactly the same. Like I can't imagine that we have to do something different. I mean, I've created the buffer, then we got to update the buffer, but let's just check something for a minute. Not that. So our positional buffer, when we do this, do we do anything else that's a bit more intense than just setting a descriptor set layout? Oh, interesting. When we do this, we actually write to a descriptor set, right? And that's actually how we update things. But if we've got this buffer device address, we literally don't have a descriptor set to update. So our updating will literally be... Yeah, we don't have this. So it's not like we update the descriptor set, because literally we don't have it. The buffer itself just kind of gets data in it, and it just turns up on the GPU, I think. Yeah, so I'll keep digging. So yeah, this is the push constant range. What am I after? I'm after how is this updated? That's the question. Like in this tutorial. I'd love to know. Hopefully you can mix like descriptor set buffers and non-descriptor set buffers. Because that would make things complicated. Where is the thing? Sorry, I've lost this. That's what I wanted. Okay, so yeah, that's not, so after this point, what? Yeah, how's it got its data in there? That's my question. We will find out. Okay, so how do I shade a... That's probably a good way of finding out. So it literally just mem copies it. Just straight up mem copies it. So I've already done this because I have initial data, I think, for this particular buffer. Set data, initial data. So I've mapped it, I've opened it and closed it, and data's in there. That's good. Oops, I've called this bindless with one S. That's not good. S, S, S. Okay. Right. Okay. So we've done that. We've done the mem copy. Okay. So we're past that. We actually don't need to worry about copying data. Now we just need to get this index onto the shader. And then do the magic that the shader requires. So I don't actually know how to do this on the shader. Again, I just thought I'd run with it and just see what happens. Today's a very like, whatever. If I figure it out, I figure it out. If I don't, I don't. So actually don't know where the shaders are for this example. Get other assets. Let's have a look. So I'm assuming that for buffers anyway, there is a slang. Ugh. I don't want. This is HLSL. Well, it looks very HLSL to me. If it isn't, I don't know. By the way, I'm not that familiar with HLSL. Is there a language to this? No. Looks like we're going to C then. No reason. Do I want HLSL? Do I want... it doesn't matter, honestly, but I'm a bit... Because I've literally only really written shaders in GLSL, I'm a bit shaky on like how the main function works and stuff like that, and I'm a bit like, well, if I'm trying to make like a I've got to then figure out like what with this buffer device address, with this HLSL shader, like what is actually the buffer device address code, so I can just ignore the rest. So so this is the fragment shader, right? So they're all together. Eschling. Okay, so that's why the Eschlang is used, because it's the entry points are all in the same file. I guess that helps with SPLV reflection, so it's not bad on it, anything like that. So this is the multiplying of the things. There's the normals, sure. The factor instance index. Yeah, where's the push constants? That's the question. Push constants. Alright, I'm just gonna have to look it up. Yeah, GLSL. I don't need that. That's just how the push constants works. Yes. Oh, maybe one of these structs was... I don't know which one's which. It's just struct. So, well, I can at least be aware that the push constant itself, I think, literally has one number in it. Input, right? VS input. I'm assuming this VS input. Oh, I see. So this is the thing that's getting passed. These are like the varyings. For, I assume, the input assembly and all that kind of stuff. Is this the... I don't think so. I don't think that's anything to do with the buffer device address thing. Yeah, like I said, I'm just gonna... we're letting it rip today. So I'm gonna... lots of ums and ahs. Okay. It's like Blim Fong. Oh, okay. Someone's gonna help. Oh, okay. Right, so we have layout buffer reference. Wow, this is pretty different. Okay, how to use it. This makes sense. Okay, let me just think about this a bit. Right, let's okay. So this is the actual data. This is the push constants. Constants buffer. Oh no, it's not. It's a no. It is. You just called it at. You did constant dot. Okay, so constants dot buffer, which is this guy. Okay. Dot data. Do whatever you want with that. Yes, we are watching. We are listening. Okay. Right, let's do the first part and we'll break it down. Yeah, because if we have a push constants, we've got to have some data to begin with. And what we can do is with the buffer thingy-majig, this guy. Oh, I see. So this is just a pointer to that. So it's literally like we're dereferencing this to... Okay. Okay, it's making a bit more sense now. So yeah, it's because that's literally what the buffer device address is. We're allowed to access pointers. So that's got to be what this is doing. Yeah, we already have this, but that's just going to be part of the push constants. Alright. 8. Yeah, thanks for that, Ratchet. So this is my Discord server. If you want to join, feel free. Links in description. So I am going to look up the individual parts of this, just so I can get a better understanding. I think I would know what I need to do, but yeah, I would like to know what the what are they called? What the things are called, you know? So this is an extension. Okay, let's enable that then. First step. We're going to use it here. No, that doesn't seem right. Is that right? That's buffer reference, bro. No. Right, I'm just going to type buffer device address because I want to see. Oops. Jeez. GLSL. I want to see the actual. Alright, okay, so. Sick. Yeah, okay, so. Oh, he's reference, okay. Oh, look up number 2. Oh, why is there always a number 2 that's slightly better than the first? Yes, I will go with number 2, I guess. That's classic Vulkan for you. Yep. So I'm just going to be reading this for a bit, so... okay, so it supports additional things. Pointer math. Alright, so you can do a pointer arithmetic on this. You can't on the other one. Fair enough, fair enough. This can be used to access arrays of structure. This can be used to access an array of structures stored consecutively. I wonder if that's SSBOs or just a list of stuff without having to push the array declaration inside the block type. Okay. The block type, what would that be? The implicit size calculations in pointer math can be used to implement size of macro. Oh, I see. Okay, so this is effectively that. Hello. Hello, Emmanuel. Hope you're having a good day. Whatever you've been up to. Alright, so 8. We want... So I'm still going to go through the... I don't know why I couldn't find this earlier. Yes, we've done this. Vulkan GLSL. Buffer reference, sure. So that's what I want to do. Alright, with what I got sent in the Discord, alignment might be what you've done. I don't know. So your buffer reference, scalar, alignment. What's the alignment? If it's scalar. I don't know. Alright, let's just read then. Okay. With scalar alignment, does that change the buffer alignment? Because a buffer... That's the question. I'm glad you're doing fine. Yeah, Vulkan is tricky. I'll be the first to tell you that one. So you're not alone. You know, I'm still learning. Like I'm literally learning right now. It's a tough one, but I think it's a worthwhile. It's fun once you get going. All right. Oh, you got DLAA working. Very nice. Well done, Ratchet. So DLLA is to do with anti-aliasing. It's like a, but we're not doing that. We're fumbling around with shaders at the moment. Yeah, congratulations on getting that working. Okay, so DLLA doesn't do upscaling. Or is that like a mistake that you made and it doesn't quite work? I don't know DLLA. 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 DLAA. DLAA. I don't know what I'm saying. What I was saying before, DLAA. There we go. Oh, music. Annoying. Come on, YouTube playlist. No, it's died. I don't know why YouTube does this. Like if you listen to a YouTube playlist for long enough, or it just does not work. Reshuffle. Oh yeah. I have no idea this is copyright. Fingers crossed. Right. Oh yeah. Right, so we need to think about this a bit. We have that moment when you open up the Vulkan spec. This music plays. Yeah, let's move on. Yeah, I'm building a game engine. I'll have to remove that from the playlist. I was just about to get copyright striked out of Oblivion. So I'm making my game engine. I'm doing it in Vulkan, and I'm currently trying to learn how to. I'm going through the foundational. I'm doing a lot of foundational work at the moment to help out with future adaptation, well, future features that I want to add. Some of my code is pretty outdated. It's doing things in the way that you would do things in OpenGL, and if I end up doing that, then it's kind of like, you know, what's the point of using Vulkan when I can, if I'm not using the features that have been updated to match more modern hardware. So that's the idea of the foundation. That's the goal. I want to lay this like proper foundation down. Yeah, thanks for the question, by the way, Pirate. Hopefully that answered it. So yeah, today's a lot of we're just figuring it out as we go. So buffer reference is the first thing that tells us what it is. So if you have scalar, does the alignment of that need to change is the question. But I guess there's only one way to find out. If I have an alignment of 8, which is what I would want for pointers anyway. Because, you know, pointers are pointers. They're 8-byte aligned on the CPU, so it makes sense. So I assume this is basically the same. Yeah, for now we're just going to comment this out. We already have a push constants. Oh. Why didn't I change this to scalar? And here's the muddy part. I have this, but I also need to add a this is what I do not understand. Finally we can place a buffer reference inside the push constants. Finally we can place a buffer reference inside a push constants SSBO or a UBO. Huh? The size alignment of the buffer is 8. Okay, that's good. So, yeah. Sure. Yeah, if we can get away with just using the push constants, that would be good. Makes sense. Unlike SSBOs, the robustness feature enables. You must do range checks yourself. Yep. It's a very good chance that we end up overriding this. Okay, I'm going to go back to the Discord for a minute. Name of buffer. Ah, okay, so this goes here. Right. I see the connections now. The neurons are firing. So we have a vertex data. For now, I don't know what's called this. That should do it. So this is now a pointer, and apparently we can access this by data. But a bit more investigation is required. Okay, so we've got this far. How do I use this guy? That's what I was interested in. So registers is this thing, references, which is this thing, buffers, which is that. Alright, so that's what I would need to copy effectively. So then I go, oops, that will get me to vertex data, and then GL index for what we need. Okay, so this should, actually we just do that right. Sure. Yep. Can I just go back to this? I assume in here we can have an a UBO type structure, right? It doesn't have to be an SSBO type. I'm going to assume that's to be true. We have the device address. No, we just need to hand it the pointer. And do this stuff. If this works, this will be very, very cool. I could probably assign this to something and then avoid all this copy and pasting, but one step at a time. Sometimes that doesn't work in GLSL. It's not like C as you can think that you've assigned something, but you haven't. It's kind of temperamental. So I'm going to be explicit as possible. There's a syntax error there. What? Let's use push constants, right? Yeah. It's not like an edom. Right, anyway. Right, let's compile this and see if it works. The shaded, that is. Yep. The shader compiled. So now we have a uint, which is 4, and a pointer, which is 8. 8 plus 4 is 462. So then we need to set the push constant range and all that kind of stuff to 12. Which is in the pipeline layout. Push constants. 12 sounds good. And push constants are really nice. We don't have to worry about when they're bound or what pipeline's being used when, etc. No, this needs to be removed. And the descriptor set is bound there. Binus descriptor set. Where's the push constants, dude? Ah, here it is. And offset. Now we just need to set the offset off of 4 to just the size. Size needs to be 12. Wait, can you do 2 things at once? I don't know. We'll just do it assuming that we could probably set up a struct, right? Offset 0. We want this to be, and this is 8. Yeah, these make less sense now. Yeah, if the size is like this, I don't know if I can do individual bits or I want to do big bits. I don't exactly know. But now we need to know what we're pushing up, which we need to get the buffer handle. So buffer resource, obtain. Obtain resource. How do I obtain the resource from here? Nice. 128. That's good. I mean, oh, interesting. Buffer device addresses can only access SSBOs. You can only access SSBOs. So that means you still need descriptor sets for uniform buffers? For uniform buffer objects? Yeah, let me... How do I obtain the resource? Oh, access buffer, that's the one. Oh, I forgot the interface to this. Well, it's a good job I started with a flipping SSBO. Because that would have been unhappy. Nope. GPU. Oh, come on, play nice. Yes, thank you. Was a return a pointer? Sure. And we will device address. Okay, so just don't use uniform buffer objects. Interesting. So you don't even use them. My use case would be like, why do I need to set this up into an SSBO? I mean, it's only used once. I mean, I can do that. It just seems a bit mad. But I guess if we're using this method. Oh. Oh, I'm in. Oh, hang on. I've done the wrong thing. Give me a second. Sorry, guys. I've messed up the shader. We should be doing this one. Not position data. I mean, eventually we'll do that for that, but I just want to do one at a time. And what we're going to do as well is we're going to remove the... just so Vulkan doesn't complain, we're going to remove the descriptor set layouts that supports this. I just hope this makes sense for the computer. You can update the push constants at different rates, I think. If they're recorded at different, like there's like thousands recorded in one loop and then like one recorded outside of that loop. I'm sure you can do a yeah, so model position reference. Okay, so model position reference, which uses this. Oh yeah, so this needs to be moved down for a minute. Scalar. This goes there. Then it's a model position, model positions. Yep. Okay. Then model position references. All right. That's correct. That's actually what I want. That's actually what I meant to do. Not the vertex positions. That's going to come later. And just compile this. Okay. At least it compiles. Next is to remove the descriptor set layout that does this, because we're going to be basically, I have a feeling we're going to get a validation error saying like, oh, the descriptor set layout you specified is not used, which, you know, is by design. So this, yeah, so I'm not going to use this anymore. Don't need that. Matrix position. Yeah, that's what I wanted to see. So now we only have one binded descriptor set. Yes, we're not destroying it anymore because there's nothing to destroy. Okay. We have the positional buffers, device address uploaded. We're not using these. I'm quite nervous now, because now we've got to debug this. Okay, let's have a go. I have no idea what's going to happen. Okay. Creation of the pipeline failed with... Oh! 4 plus 8. Huh? 16? Is a uint on a oh, I thought a uint on a shader was 4. I'm confused. What on earth would it... Okay, it's 16 for some reason. Unless I got my maths all screwed up. A 64-bit pointer is 8 bytes, right? Unless it's more. 8 plus 4 is 12. Why is it 16? Maybe buffer device address has something else. I don't know. That's very strange. Yeah, maybe I should do the size of this guy. Yeah, it's 8. Huh? I mean, I can change it to 16. It's just... Is the alignment that's causing that to happen? Maybe it's the ordering of the struct. The smallest thing needs to go at the bottom. I don't actually know if it follows the same padding rules. Like, this will now be 12 because padding is different. I don't know. Right, we have crashed. Yes. Creating a buffer. BK usage It's not valid. If VMA allocator create buffer bit address is not used. Okay. Made a mistake there, quite simple. Okay. I thought I did. Okay. Seems like a lot of... Alright, cool. So it looks like the pipeline was created, and we just got to the buffer creation and failed. What's here? Where is this crying? Create buffer, sure. Oh, is it? Oh, it's the allocator that needs it. No? Let's go to this code again. Set descriptor, nope. What is this? I'm just using VMA wrong. Ugh, I hate this. Stupid. No, it's not stupid. It's to fit on a tutorial, isn't it? That's why it's all in one line, possible to read. What is this thing? It's not that. I don't understand. I don't even have this. I assume the tutorial some code works. I haven't run it. Thank you for the hearts. I sure do need them at the moment. Debugging is a bit weird at the moment. I'm confused. I did set this. Let's get rid of transfer bit. It's not guaranteed. Sorry, it's not. This is a very unique case. All right, let's run again. Let's just change things one at a time. Yeah, you don't like that. Same error. Well, I don't even know. I should click retry at least. Retry to see where we're at. Yep, same deal. Let's have a look. There's no VMA in there. That's all Vulkan. Let's see. Did I get this wrong? Flags? It is flags. It's not anything else. Streets of Rage music is so good. What was it? It wants... Okay, so if you've used that, it's not valid if this is not used. Okay. Is that Vulkan? No, it's definitely VMA. Are these part of the same struct? That's the other question. Yeah, I'm gonna have to figure this out. So, go in here, go to find. VMA usage. What is this? This is VMA usage. Maybe this is used in two places. Yeah, okay, hang on. Oh, this is used everywhere, isn't it? Oh, that's just the code. Oh, I don't know why you are being so silly, VMA. I don't care. Just make the buffer, please. Holy. If it needs that, flag, just put the flag in. Like, why do I need to... Can't you work this out? There's nothing in here that's actually useful, is there? No. Device memory... I mean, I can set the type flags, but I feel like that's the whole point of using VMA. You don't do that. Like, what are you complaining about? I need this flag because this is how you do the bindless thing in the first place. Yeah, sorry, when I say bindless, I meant descriptor device address. You say you need this, yet... These all 432. I think that's a power 2. Yeah, they're all powers 2. They've all been all together. The flag exists. This goes in here. Does this need to be set up? No, go back. It's possible that there's like a second thing I've missed. What is this? Alright, so let's assume this works, right? This can allocate because... Let's see allocate info. Wait, how are you set up? These output variables, hang on, I've got to check what's input and output. Otherwise, we end up in a situation where... you just assigned... No, it looks like everything is... So this will be null, so it'll be assigned, I think. I just wonder if the allocator needs like some kind of flag to say, yeah, do this, please. Because I can't work out why VMA is complaining that it needs this when clearly I've set it up so it does do this. Right there. So it's like, okay, there's lots of arguments here. Is it one of the others? I've got to figure this out. Either way, I've got, I feel like I've learned a lot today, which is always good. Okay, so the allocator, how are you set up then? Is there now a special equals... Alright, we'll just go through all the allocators then. So creation allocation, so that creates the allocator. Okay, yeah, so the allocator needs this as well. Okay, so that's what I was missing. Now again, I hope I don't just destroy everything with this. Let's just pray that this doesn't break everything. Okay, it doesn't seem to break other allocations. We have a new error. Where does that put us? In the call stack. Bind descriptor set. Oh, am I binding a descriptor set? Doesn't exist now. Yes. Okay, yeah, so this strobe doesn't exist anymore. I should have really deleted this. Yeah, this isn't used. Yeah, this is all junk. Cool, yeah, so I was binding junk, basically. Junk to a piece of data that doesn't exist. Alright. Got past that. Obviously there'll be another error. Okay. So far so bad. And... let's get this zip. Nope. Literally doesn't exist. Alright. Let's see what happened. So, there's probably a shader mistake here. Hang on. I think I know what happened. I've reordered the push constants. That is... I don't understand why it's 16. But I have to assume that this is 16 for some... I mean, not 16. If it's 16, it's 12. 12 plus, yeah. So this has size of 12. This is offset 0. This is offset 12. This is size 16. And that should be our correct push constants. Because I think I was just indexing into junk memory. So, yeah. I don't understand why that's 12 bytes. But that's what the range is, apparently. Nope. That was the issue. What? Okay, let's see. So we have a, for each byte in the range, specified by an offset size for each shader stage, there must be a push constant range in the layout that includes bytes of that. Sorry, what was the just general error? Offset 12, size of 16. But the push constants range with vertex thing. But the pipeline layout doesn't have a push constants range with vertex shader bit. What is this error? Sure, right, I'm gonna do the math myself, right? This is 8. I've decided. This is 12. Oh, I don't know. Nope. Why are you complaining? Oh, I haven't recompiled. Well, maybe I have. I don't know. Let's just recompile anyway. No, we already compiled. I mean, I don't know what I expected. I mean, I'm doing something for the first time. Vulkan is awkward. I mean, like I said, I could just throw in. Yes, we are trying to go full bindless with even our buffers. We do have bindless with our textures, but we don't yet have bindless with our buffers, which we're trying to do at the moment. Because that would be really nice to have. But yeah, I'm almost. I feel like I'm getting close. Hope you're having a good day, by the way, Dietry. Hang on, this is probably copyright music. I'm glad that stopped, actually. Let's, I just realized. Nope. It's a good song, but it's definitely going to be copywritten. And press next. There we go. Sid theme. Yeah, it's I'm just learning it for the first time. That's the swap chain synchronization is, yeah, that is tough. I've got it working with binary semaphores at the moment, but I've been informed that with WSI, I keep forgetting what it's called. Apparently timeline semaphores don't play nice, which is what we need for Windows with our swap chain. Yeah, I think I'm getting pretty close. I just with binary buffers, I've just thought I would stream literally with like. I wasn't prepared, basically. I just decided, you know, let's just go and learn this on the fly. Yes, there's music. How you doing, TT? Yeah, I'm trying out music. We've run into a few potential copyright strike music, so trying to stick with just video game music, which, you know, if you're gonna live stream, you're probably gonna play video games, so I doubt that video game music is gonna strike your channel, but fingers crossed. Yeah, I don't know if you can do this. Maybe I'm doing this all silly. What I'll do actually is I'll just remove this index for now. Yeah, what I'm going to do is... yeah, BDM music should be fine, yeah. If someone has to learn Vulkan, how difficult could it be? Good question, because it depends on what you're gonna do with Vulkan. So it depends, like you can do like video encoding and decoding with Vulkan now. You can just do compute with Vulkan. You don't have to do graphics, and you can obviously, like we're doing here, graphics. So it really depends on what you're going to do with Vulkan, and it also depends on your experience going into Vulkan. Like if you're a whiz kid with OpenGL and you did lots of advanced graphics stuff with OpenGL, you're probably very familiar with how the hardware works on the GPU, meaning that yes, there will be some Vulkanisms that you have to learn, but the learning curve will be a lot less. So hopefully that answers your question. It could be difficult depending on what you do and how new you are and how much experience you have with programming. Yeah, there you go. Yeah, I'm going to simplify this a little bit and just remove this index thing from our shader. And I wonder if we don't even need this to begin with. I'm starting to think that this is actually what I want to be doing. use this as a pointer instead of having a pointer to an index, which will simplify drastically our push constants, and we won't get any silliness. And we'll actually be able to see how big this guy is, which will be good when we create the graphics, when we create the Vulkan pipeline. That's it. Dimitri just summed it up there. So D-try. Is it? I'm saying Dimitri like it's a name. D-try. Yeah, you just have to hack it away at it. Keep learning. Give yourself a bit of I don't know. Yeah, be kind to yourself when you're learning stuff. That's what I'd say. That's probably what I was trying to say. And you know, just keep going. Thank you. Right, okay. There we go. The more you know. Oh yeah, I'm also in errors at the moment. You are right. Vulkan does have threading support, and OpenGL struggles to have threading support because of how it was designed. Basically, the idea with Vulkan, when you've set everything up, you basically want, if you're going to thread things, I don't know if you've ever used command buffers, but in OpenGL they do exist too. I don't know if you've used OpenGL. I think you said you did, didn't you? Yeah, but you're embracing it. I don't know. Okay, so let's just assume that you've done some background. Basically, a command buffer, I'll just explain what a command buffer is if you don't know. You can think of it as basically a bunch of commands that you're going to send up to the GPU to execute in one go rather than individually, which is what like older graphics APIs used to do. And the idea with the multi-threading is you record command buffers in parallel, and then once you've done the parallelization of that, then you join them together at the end on submission to the graphics card. That would be a use case for using multi-threading in Vulkan. So you can have like, I don't know, shadow cascade map, depth buffers, all kind of like going at the same time as like something else. You record all that to the graphics pipeline, sorry, the command buffers, and then you join them together and submit. Right, I need to think. What am I doing? Oh, yeah, push constants. Push. Constants range. This has got to be 8, bro. I just don't understand why it's not 8 if it isn't 8. Oh, I've made a mistake in the shader? Yes, I did. Okay. Okay. Give me a second. Access the SSBO. Yeah, I've made a mistake on the shader. Give me a minute. You can do that with OpenGL. The reason that OpenGL you struggle to do that with OpenGL is because it's a giant state machine. So if you've studied data structures and algorithms, this will just be, hopefully that makes sense. So you can set something in one thread, for example, say like, I don't know, you want to disable depth testing, for example. But that affects the whole program, and that's across threads, and it kind of gets like messy. You gotta be very careful when you're just like enabling and disabling features and stuff like that. Vulkan was designed with multi-threading in mind, and that's why a lot of the work that you have to do with Vulkan is like you have to do a lot of stuff up front instead of kind of on the fly. Model position. How do I access the model positions data though? Data? I don't know. Let's just... That can't make sense. I think we're just going to get another compilation error. Warning, one, yeah. Alright, let's go back to what we did before with this index, but set this to 0. For now. There we go, yeah. This, yeah. Thank you, I'm glad you like my music tastes. Honestly, if I wasn't streaming, I'd be still listening to this type of stuff. So that worked. I think we got buffer. We literally got buffer device addresses just working then. But what I need to do next is to reintroduce the index into here. Yeah, I've got to have that in because it just doesn't work otherwise. Oh, it is. Oh, yep. Final Fantasy 13. Yeah, pretty underrated in my opinion. Oh, sorry, DSA, data structures and algorithms. I read that as you saw it as. So use direct state access. Using direct state access, I could populate multiple buffers and then upload them to the GPU in order. I'm unfamiliar with direct state access. Sorry, that's why I read it immediately as data structures and algorithms. I assumed you were talking about some kind of queuing thing or something like that that would allow multi-threading. That you would just kind of update in bulk in the end in like a multi-threaded way. Is direct state access kind of an OpenGL thing? Or is it just something I just don't know? Okay, so right, this didn't work because why wasn't it 12? Right, let's take a step back. Yeah, let's actually Google this because uint on the GLSL. We just gotta know how big this is. Like, how big is this guy? I've just got to be careful here because it's like it's a 32-bit unsigned, which is 4. That's 4 bytes. Okay, got that. Uint is 4 bytes. Yes, using DSA. We could do multiple things. Oh, okay, interesting. Okay, I didn't know that. Yes, thank you, Ewan. It's 4 bytes. And 4 plus 8 is definitely 12. I literally have to keep checking in my head because I'm so confused why Vulkan is saying the range needs to be 16. Not unless the range is 8 byte aligned and it doesn't matter. Like, that's probably what it is, right? I need to check. Give me a sec. Push constants. Is push constants? Is it aligned or something? Like, right? Okay. Yes, I'm aware of the explicit types because you can do compression and decompression of types. For me, what I'm struggling with, Ratchet, is the fact that for some reason when I have an 8 byte pointer and a 4 byte uint, the range says it needs to be 16 bytes, and I'm just wondering if it's aligned by 8 bytes. So when I'm using a push constant, it's like, it doesn't matter if it's, I don't know, let's just say you had 8 bytes and then 1 boolean, like, it wouldn't be then aligned, it wouldn't be that, you wouldn't be past, the size of that wouldn't be 8. It wouldn't be 9, sorry, I'm trying to get this in my head. It would be 8 and then another 8, so that'd be 16. I think, yeah, I'm using scalar, I think. And I think that's how C works as well. I think I'm getting this right in my head. Yeah, scalar. But I think this is aligned by the biggest type, right? This is how it works in C and C++. Structs are aligned by their biggest type. So, sorry, the unnatural, what is it called? The memory alignment is aligned by this biggest type. So this is 4. Sorry, this is 8. This is 4. So it's actually just 8 plus 8. That's actually... But I swear that's wrong. Give me a second. I just need to open up my test bed just to absolutely be sure of this. Because this is like melting my brain a little bit, to be honest. Right, so struct test. So an 8 bytes. Let's say, I don't know, const char name, that should be 8, and then no, just int x d whatever. Okay, so it says it's size 16, alignment 8. Yeah, okay, so that's what it's doing. It's following that rule. Okay, so that informs me what I'm doing now. I think I was getting the push constants confused. No. There we go. I think I was getting the push constants offsets confused with actually what I'm going to be uploading to the push constants, which is different, I think. Yeah, that makes sense. That's why it's 16, not 12. Alright, put up number 12. Okay, there's lots of 12s. Should have just looked for push constants. So yeah, this is going to be 16. We're not offsetting anywhere. And I'm not using a struct, I'm just kind of doing a push constants twice for 2 different data variables. Yeah, I might even start wrapping this into a big struct because it is kind of getting a little confusing. So yeah, this is what I'm doing, right? So we have a pointer there, and we have, I don't know what the offset, does the offset still 0? Is it 16? 16, but it's like different. Like I'm doing an I. That might be it. It might be 8 or something. It's just I'm getting this mixed up. I can't. No, it didn't like that. Oops. 0. Mm-hmm. Okay, yeah, so that works, but it's... I think I'm overriding data there. How do you send up, like, multiple things in a push constants? I think that's what I'm struggling with here. I'm getting a little confused. Does anyone know, like... I think that's what it's... I think... Because I've got... It works with one thing, but, like, when I've got two... Like this... I don't know if everyone else is doing this, basically, like a struct. Oops. Data, right? And then you just go... whatever. Like that, right? I don't know if you guys are doing that. I have a push constants with 2 values. I want to push both of them up. I don't know. I think that's what's going wrong. I don't know how to do that. I think I just need to look up the syntax, maybe. Like what? Oops. Yep, that's what I wanted. Command bar for layouts. Yeah, we'll get this. I might have to, unfortunately, end shortly. Not immediately, but it's getting a bit late. Record command buffer is okay. Yeah, layouts. Yeah, stage. Is the start of the push constants range? Oh, it's the size of the push constants range to update. So the size. So you guys. It's almost like this. From what I'm understanding. Oh. I might. Okay. I crashed my CPU. I think I briefly crashed my GPU. Is everyone still there? Alright, I'm just going to check YouTube. Give me a minute. It didn't like what I just did. Yeah, okay. We might have gone down then for a minute. Okay, still here, good. Yeah, I just lost my GPU for a minute. Okay. I think I get it. Yeah, I think I know what I was doing wrong now. I actually think no. What I'm gonna do is I'm gonna make a quick struct. We're gonna get rid of the second one. We're gonna say, just for a minute. I know this isn't ideal, but test. This is just a test, honestly. So u in there's u in 32 and index equals. Right, we'll come out of that. And then this VK device. So yeah, I think this was what was going wrong. And then we want to set the address. Again, I'll oops. Test T. I'll move this out. Actually, I could probably just construct it with positional buff. No, this please. Wrong thing. Device address and I. T and throw this in. Needs to be this. And let's see. Yo, we did it. Right, just last thing. Yeah. I'm against the clock right now, just 1 second. I'm just gonna... That was successful. And give me a minute. I want to change to docs for a minute, just to make sure this actually works. Because with docs, this actually will... it's a much simpler model. I can do 500 docs. People have seen this before, probably. The raise to 5,000. Get rid of this for a second. Now, hopefully, this will render a bunch of docs without any issue. Okay, there is an issue. Okay. Oh, wait. No, there's not an issue. Okay, it's just the light's really small. Yo, we did it. Okay, that's actually, we actually did it right. Okay, so new understanding of descriptor sets. I was just using them wrong. All right, I'm gonna have to call it here, guys. You know, honestly, thank you for turning up and chugging and putting it with my ums and ahs and reading documentation and making mistakes. Honestly, it's been a pleasure. As always, for everyone who's joined. If you're new, thank you for watching. You know, thanks for anyone who liked or subscribed as well. Yeah, you're all cool guys. I really much appreciate it. All right then, I will see you hopefully very soon in another stream. All right.